Hi, I'm Edward Jan from the Virtual Tutor Series project. I wish to welcome you to our video series on the solutions to past SSSCE and WASSCE questions. In this video, I'm going to walk you through the solutions to the 2013 core mathematics questions, focusing on part 1, which is the objective component. Solutions to the part 2 or theory component of the 2013 core mathematics questions are presented in a separate video. All our videos can be accessed on the TVTL's YouTube channel. If you need CD, DVD, or pen drive version of our videos, kindly contact us on the number below. Without much ado, let's zoom in to our classroom. Question 1. Solve the equation 2 raised to the power into bracket 9x minus 3 is equal to 8 raised to the power into bracket 3 minus x. Solution. We have 2 raised to the power into bracket 9x minus 3 to be equal to 8 raised to the power into bracket 3 minus x. Now, we need to reduce both sides of the equation to the same base before we can set the exponents equal to each other. On the right-hand side of the equation, 8 can be reduced to 2 exponent 3. So we have 2 raised to the power into bracket 9x minus 3 to be equal to 2 raised to the power 3 into bracket 3 minus x. Since the bases are the same, the only way the two expressions could be equal is for the exponents also to be the same. Therefore, we equate the exponents. That is 9x minus 3 is equal to 3 into bracket 3 minus x. Let's now expand the bracket on the right-hand side of the equation by multiplying 3 by 3 and negative x. This results in 9x minus 3 is equal to 9 minus 3x. We group like terms by adding 3 and 3x to both sides of the equation. This gives us 9x plus 3x is equal to 9 plus 3. 9x plus 3x is 12x, and 9 plus 3 is 12. So we have 12x is equal to 12. We solve for x by dividing both sides of the equation by 12. That is, x is equal to 12 over 12. 12 divided by 12 is 1. Therefore, x is equal to 1. Hence, the correct answer is option C. Question 2. Multiply 6.4 times 10 to the power 8 by 3.1 times 10 to the power negative 5 and leave the answer in standard form. Solution. We are to multiply 6.4 times 10 to the power 8 by 3.1 times 10 to the power negative 5. We multiply the two first bits of the numbers together and the two second bits of the bases together. So we have 6.4 times 3.1 times 10 to the power 8 plus negative 5. Remember that when expressions with the same base are multiplied, the indices or exponents are added. Hence, we have 10 raised to the power 8 plus negative 5. 6.4 times 3.1 is equal to 19.84, and 8 minus 5 is 3. For we have 19.84 times 10 to the power 3. This is still not in standard form. As such, we need to move the decimal point 1 digit from the right-hand side to the left-hand side. A movement of the decimal point from the right side to the left side results in positive exponents, whilst a movement from the left side to the right side results in negative exponent. So here we go. This results in 1.984 times 10 to the power 4. Therefore, the correct answer is option B. Question 3. Simplify 6/3/4 divided by into bracket 21 whole number 1/3 times 2 whole number 1/4 minus 21 bracket close. Solution. We are to simplify this expression. Let's first convert all the mixed fractions into improper fraction. 4 times 6 is 24, and 24 plus 3 is 27, and that gives us 27/4. We also have 3 times 21 to be 63, and 63 plus 1 to be 64, giving us 64/3. Finally, we have 4 times 2 to be 8, and 8 plus 1 to be 9, which makes 9/4. So we have 27/4 divided by into bracket 64/3 times 9/4 minus 21 bracket close. At this point, we make use of BODMAS by considering brackets first, followed by of, division, multiplication, addition, and subtraction. Now, 3 into 3 is 1, and 3 into 9 is 3. Again, 4 into 4 is 1, and 4 into 64 is 16. This produces 27/4 divided by into bracket 16 times 3 minus 21. 16 times 3 is 48. So we have 27/4 divided by into bracket 48 minus 21. 48 minus 21 is 27. So we have 27/4 divided by 27. Now, we need to change the division sign into multiplication by finding the reciprocal of 27. The reciprocal of 27 is 1/27. Therefore, we have 27/4 times 1/27. 27 and 27 cancel out, so we have 1/4. Hence, option C is the correct answer. Question 4. Express as a ratio the speed of 1 kilometer per minute to the speed of 10 meters per second. Solution. We are to express 1 kilometer per minute as a ratio of 10 minutes per second. To do this, we need to have both speeds in the same unit. So, let's convert 1 kilometers per minute to meters per second. 1 kilometer is equivalent to 1,000 meters, and 1 minute is equivalent to 60 seconds. So we have 1 kilometer per minute is equal to 1,000 meters per 60 seconds. 20 into 1,000 is 50, and 20 into 60 is 3. So we have 50/3 meters per second. So our ratio now becomes 50/3 meters per second is to 10 meters per second. Since ratio also acts as division, we change the sign to multiplication by multiplying 50/3 by the reciprocal of 10. So we have 50/3 times 1/10. 10 into 10 is 1, and 10 into 50 is 5. So we have 5/3 or 5 is to 3. Therefore, the correct answer is option A. Question 5. If y varies directly as into bracket 2x plus 3 and x is equal to 5 when y is equal to 52, what is the value of x when y is equal to 36? Solution. This is a direct variation, so we have y to be equal to k into bracket 2x plus 3 bracket close, where k is the constant of variation. Given x to be 5 and y to be 52. So let's substitute 5 and 52 into the equation and solve for the constant k. So we have 52 is equal to k, big bracket opens, another bracket, 2 times 5 bracket close plus 3 big bracket close. 2 times 5 is 10. So we have 52 is equal to k into bracket 10 plus 3. 10 plus 3 is 13, and 13 times is 13k. So we have 52 to be equal to 30. We solve for k by dividing both sides of the equation by 13. That is, k is equal to 52 over 13. 52 divided by 13 is 4. Therefore, k is equal to 4. Now, we are to find the value of x, given the value of as 36. We do this by substituting 4, which is the value of k, and 36, which is the value of y, back into the original equation. This gives us 36 is equal to 4 into bracket 2x plus 3. Let's now expand the bracket by multiplying 4 by 2x and 3. 4 times 2x is 8x, and 4 times 3 is 12. So we have 36 is equal to 8x plus 12. Subtracting 12 from both sides of the equation, we have 36 minus 12 is equal to 8x. 36 minus 12 is 24. So our equation now becomes 24 is equal to 8x. Dividing both sides of the equation by 8, we have x is equal to 24 over 8. 24 divided by 8 is 3. Therefore, we have x to be equal to 3. Hence, B is the correct answer. Question 6. If 4m4 base 5 is equal to 119 base 10, what is the value of m? Here is our question. 4m4 base 5 is equal to 119 base 10. To determine the value of m, we need to have both sides of the equation in the same base. Therefore, let's convert the right-hand side of the equation from base 10 to base 5. We do this by drawing up our decimal to non-decimal conversion table with columns for the base, number, and remainder. We have the number to be 119 and the base to be 5. 5 into 119 is 23 with a remainder of 4. 5 into 23 is 4 with a remainder of 3. The division is exhausted at 4. Therefore, we work upward from 4. So 4m4 base 5 is equivalent to 434 base 5. Therefore, the value of m is 3. So the correct answer is option B. Question 7. Simplify 3 over 4 root 128 minus root 32 minus 1 over 5 root 50. Solution. Given the expression 3 over 4 root 128 minus root 32 minus 1/5 root 50. To simplify the expression, we need to look for the factors within the square root in which one of them is a perfect square. For 128, we have 2 times 64. For 32, we have times 16. And for 50, we have 2 times 25. So our expression now becomes 3 over 4 root 2 times 64 minus root 2 times 16 minus 1/5 root 2 times 25. Now, the square root of 64 is 8. The square root of 16 is 4. And the square root of 25 is 5. So we have into bracket 3 over 5 times 8 root 2 minus 4 root 2 minus into bracket 1 times 5 1/5 times 5 root 2. 8 divided by 4 is 2 and 2 times 3 is 6. Again, 5 divided by 5 is 1 and 1 times 1 is 1. So our expression now becomes 6 root 2 minus 4 root 2 minus root 2. Now that we have the sets to be the same, we can conveniently add or subtract the numbers. That is, into bracket 6 minus 4 minus 1 root 2. Note that root 2 is the same as 1 root 2. 6 minus 4 is 2 and 2 minus 1 is 1. So we have root 2. Hence, the correct answer is option B. Question 8. An agent receives X% commission on every sale on product P and Y% commission on every sale on product Q. If his total sales for a particular day were $2,000 and $7,000 for product P and Q respectively, what was the total commission of the agent? Solution. The percentage of commission on product P is X%, and the total sales for product P is $2,000. To determine the commission the agent received on product P, we need to multiply the rate of commission by the total sales for product P. So we have X over 100 times $2,000. 100 into $2,000 is $20, and $20 times X is 20X dollars. So we have the commission on product P to be $20X dollars. Now, let's calculate the commission on product Q also, using the same process. We have the rate of commission on product Q to be Y%, and the total sales for product Q to be $7,000. The commission on product Q is the rate of commission on product Q multiplied by the total sales for product Q. That is Y over 100 times $7,000. 100 into $7,000 is $70, and $70 times Y is $70Y dollars. Therefore, the commission on product Q is $70Y dollars. Now, the total commission of the agent is the commission on product P plus the commission on product Q. That is, total commission is equal to $20X dollars plus $70Y dollars. Therefore, The correct answer is option C. Question 9. Solve the simultaneous equation u over 2 minus v is equal to 1 and 2u over 3 minus v is equal to 2. Solution. Here are our two equations. Let's assign 1 to the first equation and 2 to the second equation. There are different methods by which these simultaneous equations can be solved. But in our case, let's use the elimination method by subtracting equation 1 from equation 2. That is, into bracket 2u over 3 minus u over 2 bracket close minus v minus into bracket negative v is equal to 2 minus 1. Negative and negative is positive, so negative v gets rid of v. Also, 2 minus 1 is 1, so we have 2u over 3 minus u over 2 is equal to 1. We now find the LCM of 3 and 2, which is 6, and multiply both sides of the equation by this number. That is 6 times into bracket 2u over 3 minus u over 2 bracket close is equal to 6 times 1. 3 into 6 is 2, and 2 times 2u is 4u. 2 into 6 is 3, and 3 times u is 3u. Also, 6 times 1 is 6. So our equation now becomes 4u minus 3u is equal to 6. 4u minus 3u is u. Therefore, u is equal to 6. Since we now know the value of u, let's substitute this number into either of the original equations and solve for v. In this case, let's choose equation 1. So we have 6 over 2 minus v is equal to 1. Multiplying both sides of the equation by 2, we have 2 into bracket 6 over 2 minus v bracket close is equal to 2 times 1. 2 into 2 is 1, and 1 times 6 is 6. 2 times v is 2v, and 2 times 1 is 2. So we have 6 minus 2v is equal to 2. Now, let's subtract 6 from both sides of the equation. That is, negative 2v is equal to 2 minus 6. This gives us negative 2v is equal to negative 4. Dividing both sides of the equation by negative 2, we have v is equal to negative 4 over negative 2. Negative 4 over negative 2 is 2. Therefore, v is equal to 2. In a nutshell, we have u to be 6 and v to be 2. Therefore, the correct answer is option A. Question 10. If x plus 1 all over 2 minus 2x minus 1 all over 3 is less than 2, solve for x. Solution. We are to solve for x given the inequality x plus 1 all over 2 minus 2x minus 1 all over 3 is less than 2. Let's multiply through by the LCM of 2 and 3. which is 6. That is 6 into bracket x plus 1 over 2 minus 6 into bracket 2x minus 1 over 3 is less than 6 times 2. 2 into 6 is 3. 3 into 6 is 2. And 6 times 2 is 12. So our inequality now becomes 3 into bracket x plus 1 bracket close minus 2 into bracket 2x minus 1 bracket close less than 12. Removing the brackets, we have 3x plus 3 minus 4x plus 2 is less than 12. Note that negative times negative is positive, hence negative 2 times 1 is 2. 3x minus 4x is negative x, and 3 plus 2 is 5. So we have negative x plus 5 is less than 12. Subtracting 5 from both sides of the equation, we have negative x is less than 12 minus 5. 12 minus 5 is 7. Then we have negative x is less than 7. We now divide both sides of the inequality by negative 1. Note, division or multiplication of both sides of the inequality by a negative number changes the sign of the inequality. So our inequality now becomes x is greater than 7 over negative 1. 7 over negative 1 is negative 7. Therefore, x is greater than negative 7. Thus, the correct answer is option D. Question 11. Find the smaller value of x which satisfies the equation x into bracket x plus 6 over x minus 1 bracket close is equal to 12. Solution. We are given the equation x into bracket x plus 6 over x minus 1 bracket close is equal to 12. Let's expand the bracket by multiplying x by x, 6 over x and negative 1. X times x is x squared. X times 6 over x is 6. And x times negative 1 is negative x. So our equation now becomes x squared plus 6 minus x is equal to 12. We now group like terms by subtracting 12 from both sides of the equation. That is x squared minus x plus 6 minus 12 is equal to 0. We now factorize the quadratic expression on the left-hand side of the equation by finding two factors of the product of the coefficient of x squared and the constant term, which was summed up to the coefficient of x. The coefficient of x squared is 1. The coefficient of x is negative 1, and the constant term is negative 6. 1 times negative 6 is negative 6. So two factors of negative 6, which was summed up to negative 1, are negative 3 and 2. Now, let's replace negative x with negative 3x, 2x. So our equation now becomes x squared minus 3x plus 2x minus 6 is equal to 0. We now put the first two and last two terms in brackets and factorize them separately. The common factor of x squared and negative 3x is x. So the first two terms factorize into x into bracket x minus 3. Furthermore, the common factor of 2x and negative 6 is 2. So the last two terms factorize into 2 into bracket x minus 3. So our equation now becomes x into bracket x minus 3 bracket close plus 2 into bracket x minus 3 is equal to 0. It can be seen that x minus 3 is common to both terms. Therefore, we can now write x plus 2 and x minus 2 is equal to 0. If the product of two numbers is 0, then it implies that either of them can be 0. So either x plus 2 is equal to 0, which means that x is equal to negative 2, or x minus 3 is equal to 0, which means that x is equal to 3. Therefore, the smaller number of x that satisfies the equation is negative 2. Hence, option C is the correct answer. Question 12. If R is equal to h over 2 plus d squared over 8h, express d in terms of R and h. Solution. We are to make d the subject of the expression R is equal to h over 2 plus d squared over 8h. To do this, let's first get rid of the fractions by multiplying through by the LCM of 2 and 8h. The LCM of 2 and 8h is 8h. So we have 8h times R is equal to 8h times h over 2 plus 8h times d squared over 8h. 8h times R is 8hr. 8h times h over 2 is 4h squared. And 8h times d squared over 8h is d squared. So our equation now becomes 8hr is equal to 4h squared plus d squared. Let's now subtract from both sides of the equation 4h squared. That is, d squared is equal to 8hr minus 4h squared. Now, we get rid of the square by finding the square root of both sides of the equation. This gives us d is the square root of 8hr minus 4h squared. This can further be factorized as d is equal to the square root of 4h into bracket 2r minus h bracket close. Therefore, the correct answer is option A. Question 13. The sum of two numbers is 15. One of the numbers is 1.5 times the other. Find the bigger number. Solution. Since we are to find the bigger number, let's use x to represent the bigger number. We are told that the bigger number is 1.5 the smaller number. This implies that the smaller number is the bigger number divided by 1.5. That is, the smaller number is x over 1.5. Summing these two numbers up, we have x plus x over 1.5, which is 2.5x over 1.5. However, we are told that the sum of the two numbers is 15. This implies that 2.5x over 1.5 is equal to 15. Multiplying both sides of the equation by 1.5, we have 2.5x is equal to 15 times 1.5. We solve for x by dividing both sides of the equation by 2.5. That is, x is equal to 15 times 1.5 over 2.5. This results in x is equal to 9. Therefore, the correct answer is option B. Question 14. If x squared plus 1 minus into bracket x minus 2 bracket close bracket opens again x plus 1 bracket close is equal to 0, find the value of x. Solution. Here is our equation. Let's first expand the terms in the bracket by multiplying x by x and 1 and negative 2 by x and 1. X times x is x squared and x plus 1 is x. Again, negative times x is negative 2x and negative 2 times 1 is negative 2. So we have x squared plus 1 minus into bracket x squared plus x minus 2x minus 2 is equal to 0. We further multiply the terms in the bracket through by negative 1 to get rid of the bracket. This gives us x squared plus 1 minus x squared minus x plus 2x plus 2 is equal to 0. X squared and negative x squared cancel out. Negative x plus 2x is x and 1 plus 2 is 3. So we have x plus 3 is equal to 0. Subtracting 3 from both sides of the equation, we have x to be equal to negative 3. Therefore, the correct answer is option D. Question 15. The radius r of a cone is twice its height, h, in meters. Express the volume of the cone in terms of h. Solution. Here is a sketch of our cone with height h and radius r, which is equal to 2h. The volume of a cone is 1/3 the volume of a cylinder. In other words, the volume of a cone is 1/3 the area of the base times the height. The base of a cone is a circle, and the area of a circle is pi r squared. Therefore, the volume of the cone is 1/3 times the area times pi r squared times h. The radius, we are told, is twice the height. Hence, we replace r by 2h. This gives us 1/3 times pi times into bracket 2r all squared times h. 2 squared is 4. So we have 1/3 times pi times 4h squared times h. 1/3 times 4 is 4 over 3, and h squared times h is h cubed. Also, volume is measured in cubic unit. Therefore, we have the volume to be 4 over 3 pi h cubed. meters cubed. Therefore, the correct answer is option A. Question 16. In the diagram, PQ and RS are parallel chords on a circle of radius 5 centimeters. If the length of PQ is equal to 8 centimeters and the length of RS is equal to 6 centimeters, how far apart are the chords? Solution. Reproduce the circle here with center O and chords RS and PQ. Our task is to determine the length between chords RS and PQ as indicated in the diagram. The length between RS and PQ is made up of the length between chord PQ and center O, represented by H1, and the length between chord RS and center O, represented by H2. So the distance between chord PQ and chord RS is H1 plus H2. Let's now solve for H1 and H2 separately using Pythagoras theorem. For H1, we have H1 squared plus 4 squared to be equal to 5 squared. 4 squared is 16 and 5 squared is 25. So we have H1 squared plus 16 to be equal to 25. Subtracting 16 from both sides of the equation gives H1 squared to be equal to 9. We solve for H1 by finding the squared root of 9, which is 3. Hence, H1 is 3 centimeters. Let's find the value of H2 using the same process. So we have H2 squared plus 3 squared is equal to 5 squared. 3 squared is 9 and 5 squared is 25. So we have H2 squared plus 9 is equal to 25. Subtracting 9 from both sides of the equation, we have H2 squared to be equal to 16. Finding the square root of 6, we have H2 to be equal to 4 centimeters. Therefore, the distance between chord PQ and chord RS is 3 centimeters plus 4 centimeters, which is 7 centimeters. Hence, the correct answer is option C. Question 17. A pyramid has a square base and its vertical height is 12 centimeters. If the diagonal of its base is 12 root 2 centimeters, calculate its volume. Solution. Here is a sketch of our pyramid with height 8 centimeters and the diagonal of its base as 12 root 2 centimeters. The base of the pyramid, we are told, is a square. Therefore, its length and width are equal, and this is represented by x. The diagonal of the base produces a right-angled triangle. Therefore, using Pythagoras theorem, we can determine the size of the square. That is, x squared plus s squared is equal to 12 root 2 all squared. X squared plus s squared is 2s squared. So we have 2s squared is equal to 12 root 2 all squared. Now, let's root both sides of the equation in order to get rid of the square on both sides. Root x squared is x. So this gives us x root 2 is equal to 12 root 2. The stairs are the same. Therefore, x is equal to 12 centimeters. The volume of a pyramid is given by the formula 1/3 times the area of the base times the height. We have the base to be a square with side 12 centimeters. Therefore, its area is 12 centimeters times 12 centimeters. We also know the height to be 8 centimeters. Hence, the volume of the pyramid is 1/3 times 12 centimeters times 12 centimeters times 8 centimeters. This results in 384 centimeters cube, making option C the correct answer. Then 18. In the diagram, PQRS is a trapezium with length PS is equal to 7 centimeters, length QR is equal to 15 centimeters, and length SR is equal to 10 centimeters. If angle PSR is equal to 150 degrees, calculate the area of the trapezium. Solution. Here is our diagram once again. The area of a trapezium is given by the formula half times the sum of the two parallel lines times the height. In this, the two parallel lines are QR and PS. So the area of trapezium PQRS is half times into bracket length of QR plus length of PS times H, which is the height. Now, to determine the height, let's think a little outside the box by extending the power line from S to T and joining it to R. The angle on a straight line is 180 degrees. Therefore, angle RST is 30 degrees. Here are our ratios. We can now calculate the height using the ratio sin 30 degrees is equal to h over 10 centimeters. We solve for h by multiplying both sides of the equation by 10 centimeters. So we have h is equal to 10 centimeters times sin 30 degrees. Sin 30 degrees is half, and half of 10 centimeters is 5 centimeters. Therefore, h is equal to 5 centimeters. Now that we know the height, let's put it back into our formula and calculate for the area. So the area of trapezium PQRS then becomes half times into bracket 15 centimeters plus 7 centimeters bracket close times 5 centimeters. This results in 55 centimeters squared. Hence, the correct answer is option B. Question 19. The interior angles of a hexagon are 2R, 3R, 2R, 5R, R, and 2R. Find the value of R. Solution. A hexagon is a polygon with 6 sides. The sum of the interior angles of a polygon is given by the formula into bracket n minus 2 bracket close times 180 degrees, where n is the number of sides of the polygon. This implies that 2R plus 3R plus 2R plus 5R plus R plus 2R is equal to bracket 6 minus 2 bracket close times 180 degrees. So we have 15R is equal to 4 times 180 degrees. Dividing both sides of the equation by 15, we have R to be equal to 4 times 180 degrees over 15. This produces 48 degrees. Therefore, the correct answer is option C. Question 20. In the diagram, O is the center of the circle. Angle POR is equal to 108 degrees and angle ORK is equal to 20 degrees. Calculate angle OPK. Solution. Let's rotate the diagram 180 degrees to have a clear picture. Let's also introduce a chord PR. We will name the reference angle at O X and the angle at K Y. Using the following hints, let's now determine the size of angle OPK. Hint number 1. The angle subtended by a chord or an arc at the center of a circle is twice the angle it subtends at the circumference. This means that angle POR is equal to 2 times angle PKR. Angle POR is 108 degrees and angle PKR is Y. So we have 108 degrees is equal to 2Y. Dividing both sides of the equation by 2, we have Y to be equal to 108 degrees over 2, which is 54 degrees. Hint number 2. Angle at a point is 360 degrees. Therefore, angle POR plus X is equal to 360 degrees. This implies that 108 degrees plus X is equal to 360 degrees. Subtracting 108 degrees from both sides of the equation, we have X to be equal to 360 degrees minus 108 degrees, which is 252 degrees. Hint number 3. The sum of angles in a quadrilateral is 360 degrees. So for quadrilateral PORK, angle OPK plus 352 degrees, which is X, plus 54 degrees, which is Y, plus 20 degrees is equal to 360 degrees. 252 degrees plus 54 degrees plus 20 degrees is 326 degrees. So we have angle OPK plus 326 degrees to be equal to 360 degrees. Subtract 326 degrees from both sides of the equation, we have angle OPK to be equal to 360 degrees minus 326 degrees, which is 34 degrees. Therefore, the correct answer is option B. Question 21. Find the value of X in the diagram. Solution. Again, let's rotate the figure 90 degrees clockwise in order to have a clear picture. We need to think a little outside the box by extending the parallel lines. Now, let's name the other base angle of the triangle, Y. We now find the value of X using the following hints. Hint number 1. The sum of two interior opposite angles of a triangle is equal to an exterior angle. This means that 20 degrees plus Y is equal to 75 degrees. Therefore, Y is equal to 75 degrees minus 20 degrees, which is 55 degrees. Hint number 2. Corresponding angles are equal. This implies that x is equal to y. Therefore, x is 55 degrees. Hence, option C is the correct answer. Question 22. Adam drew a straight line xy on a plain sheet of paper. Using a pair of compasses with center x and a convenient radius, he drew an arc intersecting xy at P. Using the same radius P as the center, he drew another arc to intersect the first arc at T. He joined T to X and read off angle TXP with a protractor. What value did he read? Solution. We first draw the straight line xy. At center X and a convenient radius, let's now draw an arc to intersect line xy. Let's name the point of intersection P. With our compass at P and same radius, let's draw another arc to intersect the first arc. Let's name the point of intersection of the first arc and the second arc T. We now join T to X, and the angle constructed is obviously 60 degrees. Therefore, the correct answer is option C. Question 23. A bird on top of a tree 50 meters high was observed at an angle of elevation of 75 degrees from the horizontal ground at the foot of the tree. Calculate, correct to the nearest whole number, the distance of the observer from the foot of the tree. Solution. Here is a sketch of our bird sitting comfortably on top of the tree. We are told that the tree is 50 meters high. The angle of elevation is the angle between the line of sight to an object above the observer, in this case the bird, and the horizontal line. This is given as 75 degrees. Now, let's use x to represent the distance between the observer and the foot of the tree. Here are our ratios. We now have a right-angled triangle, and we can find x using the ratio tan or tangent, which is the opposite side divided by the adjacent side. The opposite side relative to angle 75 degrees is 15 meters, and the adjacent side is x. So we have tan 75 degrees is equal to x over 15 meters. Multiplying both sides of the equation by 15 meters, we have x is equal to 15 meters times tan 75 degrees. This is approximately 3.73205 meters, which can be written as 4 meters to the nearest whole number. Therefore, the correct answer is option A. Question 24. If tan x is equal to 1 over root 3, where x lies between 0 degrees and 90 degrees inclusive, find sin x minus cos x. Solution. Let's sketch our right-angled triangle with one of the angles being x. We also have here our ratios, sine, cosine, and tangent. The tangent of an angle is the opposite side divided by the adjacent side. So if tan x is 1 over root 3, it means that the opposite side is 1 and the adjacent side is root 3. To be able to calculate the sine and cosine of x, we need to first determine the hypotenuse. Therefore, let's use A to represent the hypotenuse. Now, using Pythagoras' theorem, we have A squared is equal to 1 squared plus root 3 squared. 1 square is 1 and root 3 square is 3. So we have A square is equal to 1 plus 3. 1 plus 3 is 4. So we have A square is equal to 4. Finding the square root of both sides, we have A to be equal to root 4, which is 2. Sine of an angle is the opposite side over the hypotenuse, and the cosine of an angle is the adjacent side over the hypotenuse. So, sine x minus cos x is 1 over 2 minus root 3 over 2. This can be further simplified as 1 minus root 3 all over 2. Therefore, the correct answer is option A. Question 25. If the bearing of R from Q is 135 degrees, find the bearing of Q from R. Solution. We can solve this question using the reversal bearing rule, which states that if the bearing of B from A is theta degrees, then the bearing of A from B is theta degrees plus 180 degrees. If theta is less than 180 degrees, theta degrees minus 180 degrees if theta is greater than 180 degrees. The bearing of R from Q is 135 degrees. For the bearing of Q from R is 135 degrees plus 180 degrees, since 135 degrees is less than 180 degrees. 135 degrees plus 180 degrees is 315 degrees. Hence, the bearing of Q from R is 315 degrees. We can also determine the bearing of Q from R using a simple sketch. First of all, we have point Q. Bearing is measured in the clockwise direction from the north. So a bearing of 135 degrees from Q is 135 degrees from the north, ending in the southeastern direction. We then extend the line from Q to R. So here is point R. Quadrant is 90 degrees. Therefore, half of the quadrant is 45 degrees. Alternate angles are equal. So this angle is also 45 degrees. The bearing of Q from R is measured from the north of R to the northwest. And as said earlier, each quadrant is 90 degrees. Therefore, the bearing of Q from R is 90 degrees plus 90 degrees plus 90 degrees plus 45 degrees, which is equal to 315 degrees. Hence, the correct answer is option D.